In the previous lesson, I showed you nested serialization. In this lesson, I'm going to show you more about view sets and how to do custom actions. A common pattern in the REST world is to declare an API that includes multiple objects. Up until now, the view sets and the routers you've seen have been object-specific. If you were going to be creating a single-page web application, you might want one REST call that includes all of the objects that you want back. So it would contain a dictionary, and the dictionary would then have keys for each type of object that's coming back in your page. The view sets methods that I've shown you up until now have been object specific, so that technique won't work in this case. Instead, I'm going to start by showing you how to declare a view and nest those multiple serializers inside of it. New lesson, new app. This time I'm going to create a new app called API. As always, with a new app, you need to install it in the installed apps listing, add the path for the app into the URLs file, and just to throw you a curveball this time, I'm going to add a little wrinkle. It's a good idea to include a version number in your API path. This allows you to do backwardly incompatible changes with your API by declaring a new version number while maintaining backward compatibility while someone hits the old URLs. An easy way of doing this is inside of the path declaration inside of your URLs file. I'll show you what I mean in a moment. As before, if you're coding along with me, the changes to the views and URLs files will need to be done in conjunction. For the moment, I'm going to be using the data that's already in the database, so you shouldn't need to do any migrations this time. Here's the new view that I'm going to include inside of my API app. Let me just scroll down. The view starts on line 12 with the API view decorator indicating that this is going to be a get view. This view is going to include two different types of information, both the doctors in the person objects and the vehicles. For a little variety, this time I'm changing the query set that's being serialized to be just the doctors, so I'm filtering on anyone with the title doctor. And one other complication arises here as well. I hinted at this in the previous lesson. You may recall that the vehicle serializer uses the URL field. In order to properly populate the URL field, the serializer needs to be aware of the request. When you use a view set, the view set does this automatically for you. Because I'm not using a view set here, I need to pass extra information into the vehicle serializer so that it can see the request object. This is done through the context parameter. The context parameter is similar to the context parameter that you would use in a Django template. It's a dictionary containing, in this case, just the request field. So the serializer includes the vehicles being serialized. Because it's multiple vehicles, many equals true, as well as the context that includes the request object. The serializer then uses the request object out of the context to construct the host name inside of the URL so that you can get a fully qualified URL inside of the serialized payload. On line 23, I'm using the person serializer to serialize the doctor's query set. Notice that what goes in the dictionary is actually the data attribute. So I've shortcut here rather than creating an object called the serializer and then calling data on the object. I'm just doing it directly on the constructor in one line. Then on line 24, I serialize the vehicles like you've seen me do before and return all of this inside of a REST response object. Inside the APIs app, I create an URLs file and I register the listing that I just created. Notice that I've named the path v1 listing. This is me versioning the API. In the future, if I were going to create a new, backwardly incompatible listing, I could continue to use the old code under v1 and create a new path under v2. This allows me to deprecate an old API without removing it yet, maintaining backward compatibility for my users. In a window off screen, I'm running the Django development server, and here I'm going to hit it with curl. Version 1 of the API, piping it through the JSON pretty printer, and there's the results. Let me just scroll this back up so you can see everything. The return is a dictionary containing the field doctors and the field vehicles. The doctors field contains an array with all of the doctors, and the vehicles field contains an array with all of the vehicles. Scrolling back down, as before, the vehicles includes the nested part set inside of it, and notice the URLs being used in both the vehicles and part objects. Because I used a view instead of a view set that time, I'm not able to register the view with a router. As a result, you don't get the meta listing of all of the possible views in the root path. But what if I wanted it? Well, you can do anything with a view set that you could do with a view, so this is possible. Here's a new view set that I've added to the views file. I'm not doing anything here that you haven't seen before, I'm just doing it in a slightly different format. The declaration of the class of the doctor's view set inherits from two classes. The first class is the generic view set. Because this is a view set, that kind of makes sense. The second is a mixin. This mixin indicates which actions, and therefore which HTTP methods, will be supported by this view set. In this particular case, all I'm including is the list. So this view set will only support listing objects. For each mixin that you include, you will have a corresponding method. For the list model mixin, I have the list method. Inside this list method, I'm not doing anything you haven't seen before. I'm serializing the doctors, putting those inside of result, and returning a REST response. So here's the new API's URLs file. Since I'm now using a view set instead of a view, I use the router to register it, and I include all the URLs provided by the router, in this case it will only be one, under the v1 path listing, giving me version numbers for my API. Once again, hitting the dev server with curl, and pretty printing it. And there's the result. I'll miss you, Sir Connery. The DRF provides an entire hierarchy of viewSet classes for your use. There's the base viewSet class, the generic viewSet class that I just showed you, which adds the querySet attribute, the getObject and getQuerySet methods, the model viewSet that you've been using in the lessons up until now, and there's also a read-only model viewSet that is a model viewSet but doesn't allow changes to it. Several lessons ago, when I introduced viewSets, I showed you this base class. It's probably worth reviewing now. The base viewSet declares 6 methods that correspond to the actions that are being performed in REST. List lists objects. Create is for a post, creating an object. Retrieve is to get a specific object. Update and partial update are for updating existing objects. And destroy is for deleting an object. Each of these methods is declared inside of a mixin. It's done this way so you can mix and match the mixins and create a view set with only those methods that you wish to support. The mixins are create, list, retrieve, update, which provides both update and partial update methods, and destroy. Essentially, there's a mixin for each one of those methods I just showed you in the base class. Additionally, if there's something that you want to do that isn't covered by one of those actions, you can declare your own. You do this by adding a method to a viewSet subclass and then decorating it, indicating that it's an action. One of the more common purposes for this is mass operations. REST, by default, doesn't support the change of more than one object at a time. For example, if you wanted to be able to delete multiple objects, you would have to make multiple calls. Instead, you can create an action which is mass delete. Let me show you how to do that right now. Here's my mass delete viewSet that I'm adding to the views file. First off, I have to inherit from generic viewSet so that this is a viewSet. Secondly, this viewSet is only going to support deleting objects, so I'm going to use the destroy mixin. Inside of the class, I'm creating a method called massDelete, and I tell DRF that I want this to be an action available in the REST API by decorating it with the action decorator. I'm passing two arguments to the decorator. The first is detail equals false. This tells the DRF that the URL to be used with this action does not include an ID. Because I'm going to be deleting multiple objects, I just want a regular URL. I don't want /3 on the end of it. Secondly, I'm passing in a list of the HTTP methods that I'm supporting in this action. In this case, it's only delete. Because I'm deleting more than one thing, I somehow have to get multiple IDs up to the server. There's different ways of handling this. I could use get with query parameters, or in this case, what I'm showing you is using a post with a string inside of it that is comma separated. When this action is called, I will process the post field named IDs and split it on any commas inside of it. Each value that is found is assumed to be the ID of an artifact that needs to be deleted. I fetch that artifact and then call the delete method on it. Finally, because there's no payload that I want to return, I just send back an empty response object. And here's the updated URLs file. You'll need to register the mass delete artifacts view set with your router, adding it to the already existing doctor's registration. Let me run a query just to show you what data is available for the artifacts before I delete anything. And there are my two artifacts. And now I will call mass delete. I specify $X delete so that I use the HTTP delete method with curl. And the -d parameter shows the post fields that I'm going to be sending in of 1, 2. Notice that the URL is a little weird that you've got the mass delete twice. This has to do with how the router constructs URL names. It's based on both the class name and the method that is attached to it. There are things you can do to modify this, but you kind of have to jump through hoops. It's easier just to accept it as it is. Finally, to show you that this worked, I'll run the get again. And object 1 and 2 have been deleted, so there's nothing left. Next up, I'm going to leave Fedora behind and show you a new sample application that's almost a single-page application to show you how this works in the root. In the previous lesson, I showed you how to add actions to view sets. In the next two lessons, I'm going to run through a single-page application and how you could use the DRF to help you build one. Single-page applications have become a popular way of building things on the web, and REST is a common protocol to be used with these SPAs. Single-page applications are split into a front-end and back-end. Django can be used for traditional web or as the back-end for an SPA. Your Python code on the server side includes managing any sort of business logic, and then you can use the Django ORM and database for storage. On the front-end side, there are plenty of frameworks out there to help you build SPAs. Vue, React, and Angular are some of the more popular ones. To demonstrate how the DRF can help you write these kinds of applications, I'm going to show you a small SPA. The S is a bit of a lie. I'm actually going to build two pages. The first will be a traditional web one that just lists a series of schedules, and then the second will be a wholly contained timeline editor, which allows you to edit the timelines associated with those schedules. I'm going to be using the Vue.js library to do this. Vue is a model view JavaScript frontend that uses declarative rendering. What that means is you pass it some JSON, and you apply HTML templates, and as the JSON changes, Vue automatically updates the templates. If Vue interests you, you can find out more about it at its homepage here. In addition to Vue, I'm going to use a couple of libraries that I've written myself. They're open source and available on PyPI, so if you find them useful, go for it. The first of the two libraries is called Django All. It's kind of a catch-all library for me. It contains a bunch of tiny little pieces of code that I've used over and over again in different Django applications, but none of them were large enough to warrant their own package. One feature in particular that I'm going to use is called a ranked model. The ranked model is an abstract Django model that manages ordering of objects. If you'd like to see the source code for Django All, it's available on GitHub. I'm also happy to take bug fixes and contributions. Feel free to submit a PR. Django All has been tested in production code, but nothing at a huge scale yet, so I don't promise it won't fall over. I can't say the same about the next one. Django Bootstrap Models is a series of modal dialogues in Bootstrap and includes REST-specific dialog boxes. This one's also available up on GitHub, but unlike Django All, this has only ever been used for prototypes. It's probably okay, but caveat emptor. So here are the pieces of the schedule app. On the data side, there's a Django app called Timeline with a models file inside of it. It declares two objects for the ORM. The first is a timeline object, which really is just a container for entries in a schedule, and the second is the entry itself. The entry contains a description and a time length. There's another Django app that's responsible for the REST API. Inside of it, you'll see serializers.py containing a serializer for each timeline and entry, a views.py file containing a view set for each timeline and entry, and then additionally another view called changeRank. The entry object inherits from Django All's ranked model class. This is what specifies the order of the entry inside of the timeline. Ranked model has logic inside of it that ensures the ranks are consistent if one of them changes. This logic is done in an overridden save method. Unfortunately, the DRF's update methods don't actually call an object's save, so the side effects that are done as part of ranked model's save method will not get called if you make a change to the rank through the REST API. So as a result, I've written an additional view called changeRank, which specifically calls the entry's save method to ensure that the rank reordering happens properly. Here's how things work when a user hits the application on the browser. First off, you visit the timeline page. That hits a view on the Django side. That's inside of the timeline app in its views file. The view is called Edit Timeline, and it renders a template called Edit Timeline. That template contains HTML as well as the Vue.js components. The Vue.js components initialize, and then as part of the initialization, the Vue component will make a REST call to fetch the timeline that's being edited. That REST call goes to the API on the Django server and hits the timeline view set. The timeline view set serializes the timeline, which then serializes nested entries, and those are returned back to the browser application as JSON. That JSON is then used by Vue.js and its internal templating mechanism to present the actual page. Inside of the client application, there are a few things you can do. The first would be to add a new entry. When that is triggered, Vue.js calls a method on a form. That form is a Bootstrap model form. The method is showCreate. ShowCreate takes a REST API URL, in this case the one for entries, and some data for the entry that is to be created. The ID of the timeline and the rank are set by default. The ID of the timeline is the parent timeline for this page, and the rank is set by default to one more than the highest ranking item on the page at the moment. A form is displayed. When the user submits the form, the data from the form, as well as the hidden timeline and rank fields, gets sent to the server by showCreate. This is a REST call. That hits API v1 entries, creating the object on the server, which responds back with JSON of the object created, and that's populated inside of Vue.js. A similar process happens when an entry is edited. The same form is used, but this time it calls a method called showPatch. ShowPatch takes two parameters: the URL of the object being edited. This would be the entry object inside of Vue.js that's actually being edited, and its URL attribute, and then the data from the actual entry object. ShowPatch shows the same form, pre-populated with the data from the entry object. The user can then make changes. When they save the form, Bootstrap Modals makes a REST call. That REST call is to the entries object with the given ID, sending up the fields from the form and patching them on the server. The REST call returns the resulting changed data, and Vue.js is populated with the change and the change is reflected on the screen. The other possibility is one entry is dragged around on the screen, changing its order. This is done through a library called VueDraggable. VueDraggable has a hook on it for the onMove event. The function that is called in the onMove event figures out what entry has been changed and calls through REST the change rank call. This passes in the ID of the entry being changed and the new rank. That calls the specialty view that ensures that entry's save method gets called, which makes sure that all the ranks are set correctly. And in this case, because multiple ranks may change, the change rank view returns all of the entries for the timeline. Vue.js then updates its copy of it based on the JSON returned and then updates the screen. I hope this gives you a little bit of a glimpse of how these things work and how you can quickly slap together some items with very little code on the server simply by using something like the REST APIs you've seen in this course. Next up, I'll take what I just showed you in pictures and show it to you in code. Just as a little warning, it'll be both Python and JavaScript to show both parts of the code. Be prepared.